Okay, for our warm-ups, it gives us several functions here and gives us some values that we are supposed to substitute in and solve. So on the first question, it says, given that g of x is x squared minus x, find g of negative 3. Well, just like it says here, normally in that parenthesis we have an x. So this right here tells us that x is negative 3, meaning that we should substitute in negative 3 anywhere we have an x. So for this function, if we are looking for g of negative 3, then we should have negative 3 squared minus negative 3. When we simplify, we should use order of operations, meaning we would take care of the exponent first. So we would have negative 3 squared, which would be 9. Remember, if you're going to put that in a calculator, to put parentheses around the negative number so that it will square the negative and the number, not just the number. And then after we have done our exponent, then we can subtract. Now it does have minus a negative number here. As we know, two negatives will make a positive, so this is really 9 plus 3, which gives us 12. All right, for number 2, find g of x given g of 5. This means that x is equal to 5. So in our function, we are going to plug in 5 anywhere we see an x. So we'll have 3 times 5 minus 4 times 5 squared plus 2. Again, we would do order of operations when simplifying, so exponent first. So my exponent right here is going to turn this into 25. So we're going to have 3 times 5 minus 4 times 25 plus 2. All right, after we've taken care of the exponents, then we can multiply. So really we're going to have 15 minus 100 plus 2. So then we add and subtract going from left to right. So 15 minus 100 would be negative 85, and negative 85 plus 2 would give us negative 83. All right, and then for number 3, it says, given g of x is equal to x plus 5x plus 5, find g of k. So this information right here tells us that x is equal to k. That means anywhere there is a term x, we should replace it with k. So g of k would be k plus 5k plus 5. All right, now that we did substitute in, although there is still a variable, we look for any like terms that we could simplify. We do have k and 5k, which are like terms. We're supposed to add those together, so that would give us 6k plus 5. All right, so there is our warm-up. Then they give us a little bit of information here on the notes to remind us how sum, difference, product, and quotient rules are written and what exactly they mean. So it says here, if you have f plus g of x, what that really means that they want you to do is add your f of x and your g of x together. If you have f minus g of x, what that really means to do is to subtract f of x minus g of x in that order. If you have f times g of x, this means to multiply f of x times g of x. And if you have f divided by g of x, this means to divide f of x by g of x. And this will work as long as g of x does not equal 0. Remember, we cannot have 0 in the bottom of a fraction. All right, so keeping this rule in mind, it says if f of x is equal to x squared plus 1 and g of x is equal to x minus 3, find a rule, or in other words, write the equation for the following. It does say an equation because in these particular cases, we are not going to be able to simplify down to a numeric answer because there's going to be variables in there. All right, so f plus g of x. Remember, our rule from up above says what this really means is f of x plus g of x. And in this particular case, we were told that f of x is equal to x squared plus 1, and g of x is equal to x minus 3. So for f of x, we'll have x squared plus 1 plus g of x, which is x minus 3. And then we just simplify this as much as we can. So we have x squared. It does not have any other like terms, so I'll leave it as x squared. Next we have x, no like terms for that one either, so just x. But we do have a positive 1 and a negative 3. Those are constants, so those are like terms. We add them together, we've got negative 2. So we're left with x squared plus x minus 2. Part B says to find f minus g. So for f minus g, we would have f of x minus g of x. So we would have x squared plus 1 minus x minus 3. Now, I would put that second term in parentheses because we are subtracting the entire g of x, not just the first term. So make sure you put this in parentheses here to remind you you're subtracting the entire term. So what that really means is that I'm subtracting the x, but I'm also subtracting negative 3. So really, this would be x squared plus 1 minus x plus 3, because if I subtract a negative 3, that's going to become a positive. And then again, we'll combine our like terms, so we'd be left with x squared minus x plus 4. All right, for part C, it says f times g of x, so this literally means f of x times g of x. All right, so we would have x squared plus 1 times x minus 3. All right, so remember this means we're going to have to FOIL it out or multiply every piece in the first parenthesis by every piece in that second parenthesis. So we'll have x squared times x, which would be x cubed, x squared times negative 3, which would be negative 3x squared. Then we have 1 times x and 1 times negative 3. So then we will combine our like terms. We'll have x cubed minus, looks like we actually don't have any like terms, so this one will stay exactly as it is. So x cubed minus 3x squared plus x minus 3 is what we would be left with here, since there's no like terms to combine. All right, for part D, we've got f divided by g, so this means f of x divided by g of x. So in this particular case, that's going to be x squared plus 1 over x minus 3. Now we would look to simplify. In this particular case, there's not really going to be anything we can simplify because there's nothing that will divide out as is, and that top piece cannot be factored. So this would be as simplified as that's going to get. All right, so hopefully that was just a little review for us. It says here we are now going to look at composite functions. The easiest way to describe a composite function is to say it's like substitution, so taking something and substituting it in or plugging it in for something else. So if you see something as f of g of x, this is what we call a composite function when it's written in this way. What this really means is f of g of x written this way. So really what we're going to be doing is taking g and subbing it into f. So it says this is read as f of g of x, which means to substitute g of x in for x in the f of x expression. So let's turn it over onto the back of the page. And here's just a little way to help you with remembering how to substitute this information in if you need it. It says if the composition has a v, which is going to stand for variable, on the inside, start with the outside of the function and work your way in. If your composition has a number on the outside, a number on the inside, start with the inside function and work your way out. So let's keep that in mind. So it says on example number 2, if f of x is 2x plus 3 and g of x is 8 minus x, find the following. So we're going to have f of g of x, which, as they wrote for us on the previous page, remember that means f of g of x written this way. Or in other words, we're going to take g and we're going to substitute it in to f. So this would be f of g of x. Well, g of x, as we know, is 8 minus x. So that means I'm going to plug 8 minus x into our function f. So our function f is 2x plus 3, but as we just said, this is my new x. So I'll have 2 times 8 minus x that I sub in. And then I finished writing that function, so I got my plus 3 on the end. And then just like what we were doing on the front, once we get to this place, we simplify. So I've got a number here in front of that parenthesis. So we are going to distribute. So I'll have 2 times 8, 2 times negative x. So I'll have 16 minus 2x plus 3. Then we do have some like terms here. So we end up with negative 2x plus 19, or 19 minus 2x. All right, then for part B, we have g of f of x. So this would mean we have g of f of x written this way. In other words, this time I'm going to take f and plug it into g. So our function f is 2x plus 3. So I'm plugging 2x plus 3 into g. So my function for g was 8 minus x. But as we just saw right here, I'm supposed to replace x with 2x plus 3. Make sure you put that in parentheses because remember, we are subtracting the entire f of x. So I need to make sure that this negative is going to go to that entire parenthesis, not just the 2x, but also the 3. All right, so we distribute that negative, and we have 8 minus 2x minus 3. Or if we combine those like terms, we have negative 2x plus 5. All right, and then we have questions A and B here. So they tell you that your f of x is x squared minus 2x plus 3. And then you are also given that the g of x is the square root of x. And they ask you to find the following. So I'm going to give you just a minute. I want you to try substituting those in like we did on A and B above with these two functions. So you can try those with a partner. I'll give you just a moment to do that. Okay, so let's take a look at these two examples and check what we got. So this first one asks us to find f of g of x. So I'm going to take g and plug into f. So f of our square root of x. So we would have x squared, but I replace x with square root of x, minus 2 times, instead of x, square root of x, plus 3. So, order of operations tells me to take care of this exponent first. That square and that square root are going to simplify out to just leave us with x. And then we have negative 2 times the square root of x, which would just be negative 2 square root of x. And then we have our plus 3. Those are not any like terms, so nothing else to combine, so we're good there. For this one, we have g of f of x, so this time I'm going to plug in f to g. So I'll have g of x squared minus 2x plus 3. So we would have the square root of, but instead of x, we've got x squared minus 2x plus 3. And if I was going to take the square root of one piece of this, I have to be able to take the square root of all of it. And there is no square root of negative 2x or 3, so this would be it. All right, so for these these 3 here, it says, think about if f of x was x squared plus 1 and g of x was x minus 3. And they want us to find the following. So now we're going to go back to what we were doing there on the front, where we are, for this question, multiplying, for this question, subtracting, and for this question, adding our terms. All right, they did tell us here that instead of x, we now know that x is 2. So I would need to find f of 2 and multiply it by g of 2. So I'm going to need to evaluate both of my functions. So at 2, for f, that would be 2 squared plus 1, which would simplify to 5. And for g of 2, I'd have 2 minus 3, which would be negative 1. And here they did ask us to multiply these two values together. So we would have 5 times negative 1, which would be negative 5. All right, for part B, we're evaluating x as negative 4. So here I know that x is negative 4. So we would need to evaluate f at negative 4 and g at negative 4. So for f, we would have negative 4 squared plus 1, which would be 17. And for g, we would have negative 4 minus 3, which would be negative 7. Now the order does matter here. We are subtracting. It said g minus f, so that means g of negative 4 minus f of negative 4. So g of negative 4 was negative 7 minus f of negative 4, which was 17. So negative 7 minus 17 is going to give us negative 24. All right, and then for this last one, we are adding, and we are told x is negative 2. So first I'm going to find f of negative 2. So that would be negative 2 squared plus 1, which would give us 5. And g of negative 2, which is going to give us negative 5. All right, and they did say we are adding here. So I'm looking for f of negative 2 plus g of negative 2. Our f of negative 2 was 5, plus our negative 2, g of negative 2 was negative 5. So when we add these together, we get 0. All right, and then for example 4, it says, given f of x is equal to x squared, g of x is 2x plus 1, and h of x is the cubed root of x, find the following. All right, so these ones are a little bit more of a challenge problem. So we start on the inside. So here, the innermost piece would be this h of negative 8. So I'm going to look over here. Here's my h. H is the cubed root of x, and we are told right here that our x is negative 8. So the cubed root of negative 8. So cubed root means something that multiplies times itself 3 times to get us this number, negative 8. The only thing that multiplies times itself 3 times to get you negative 8 would be negative 2. So I now know that this h of negative 8, this whole piece here, is equivalent to negative 2. So now I have f of g of negative 2. All right, so now I'm going to evaluate g of negative 2. So here's my g of x function. So I'm looking for g of negative 2, which would be 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is negative 3. So now I know that this piece is equivalent to negative 3. So really, I'm looking for f of negative 3. And f of negative 3, I come look at my function here. I replace my x with negative 3, and I have negative 3 squared, which gives us 9. All right. Same idea for part B. We start with the innermost piece first, which is g of 13. So I'm going to come back up here. Here is g. So I'm going to evaluate g of 13 to find out what that piece is. So I'd have 2 times 13 plus 1, which would be 27. So this piece right here is 27. So really, we have f of h of 27. So now I'm looking at h of 27. So I come back up here, here's h. So I would have h of 27 is the cubed root of 27. So what multiplies times itself 3 times to give us 27? That would be 3. There is also a function in your calculator to bring up a cubed root. I believe it's math. Let me check. Let's see here. Yes, on your graphing calculator, it's math number 4 if you're needing to take a cubed root in your calculator, if it's something too large that you're not familiar with the cubed root of. All right, so now we know that h of 27 is 3, so this can be replaced with 3, so I'm looking for f of 3, which would be 3 squared, which is